Welcome to Life Redacted, your trusted source for all things related to living life. From practical tips to thoughtful insights, we're here to help you navigate the twists and turns of everyday living. Whether you're looking for advice for your next purchase, inspiration for your next project, or just, a fresh perspective on what's going on in this world, you've definitely come to the right place. Love what you're hearing? Hit that subscribe button to stay in the loop on our latest episodes. And hey, don't forget to give us a like if you're enjoying the show. It means the world to us and helps us reach more amazing listeners like you. Now, before we dive into today's topic, let's talk for a moment about something truly vital to your health, and specifically, your skin. Did you know that your skin isn't just your largest organ? It's also one of the most crucial for protecting your entire body and supporting your overall health. And this really matters because, well, what you put on your skin gets absorbed. Some studies suggest up to 80% can enter your body. So it makes you think, doesn't it? Why use conventional skincare products that are often packed with, frankly, harmful or toxic ingredients? Things that might actually do more harm than good to that vital protective barrier. At Face Naturals Organic Skincare, we believe in a different approach. We're all about nurturing your skin with ingredients that are safe, natural, and genuinely effective. Ingredients that support your health and well-being, not work against it. So we encourage you to visit facenaturals.com. That's FACENATURALS.com. Explore their range of natural skincare products designed to protect and nourish. And you can save 10% on your next healthy skincare purchase. Remember, healthy skin starts here. Okay, so shifting gears now from our body's protective shell to the sophisticated tech that many of us carry around every single day. Today, we're doing a deep dive. We've got sources comparing the technical evolution of Apple's biggest phone, the iPhone Pro Max series. We're going to track the journey, from the iPhone 14 Pro Max right through to what we expect from the upcoming iPhone 17 Pro Max. Right, let's unpack this. We've looked at a bunch of sources, and they really get into the weeds, treating these phones almost like, well, engineering specs. Our mission here is pretty clear. Cut through the marketing noise, extract the raw engineering differences, the real silicon changes, the sensor upgrades, the material science involved. We want to separate the genuine innovation from, the surface level stuff. The goal is to empower you, our listener, so you can make a truly informed decision based on hard data, not just the shiny ads.
And that's so important because the sources really do confirm that the jump across these generations, especially from the 14 Pro Max to what's anticipated for the 17 Pro Max, it's substantial. It's not just incremental tweaks here and there. We're talking about fundamental shifts. Think about the silicon going from a 4-nanometer process to an advanced 3-nanometer one, or the display moving from OLED, which was already great, to potentially micro LED. These are core changes. 3 years in mobile engineering. That's practically an eternity. These changes impact everything: performance, how the phone feels in your hand, how long the battery lasts, the camera, everything.
That really sets the scene. Okay, let's start with something tangible, something you can actually feel. Section 1, design and build quality. This is where material science meets precision engineering. So the iPhone 14 Pro Max, that really laid the groundwork for the current design, didn't it? It used that surgical grade stainless steel frame, super durable, yes, but also heavy.
Yeah, that one clocked in at 240 grams. It felt like a tank solid, premium, but definitely hefty. You notice the weight. Dimensions were 160.7 by 77.6 by 7.85 millimeters. That was the benchmark.
Right. And then came the 15 Pro Max, which felt like a really significant pivot.
It absolutely was. The big story there was the move to grade 5 titanium for the construction. Now, grade 5 isn't pure titanium. It's an alloy, mostly titanium with aluminum and vanadium, the key benefit. A much better strength-to-weight ratio compared to that stainless steel. And, impressively, they kept the dimensions pretty much identical to the 14 Pro Max, but dropped the weight significantly, down to 221 grams.
That 19-gram difference, it sounds small on paper, but you really feel it, don't you?
Oh, immediately. Holding it feels different. Less fatigue, maybe feels a bit more balanced in the hand. It was a huge win for just, everyday usability.
Okay, so that was the big material shift. But the sources suggest the evolution didn't stop there. The 16 Pro Max apparently refined things further, maybe tightening tolerances between the titanium and the aluminum inside.
Exactly. More about refining the manufacturing process, making that bond even more precise. But the 17 Pro Max looks like it's bringing another step change in the material itself. The term being floated is aerospace-grade titanium alloy.
Ah, the classic aerospace grade. I have to ask, is that just marketing speak, or is there something technically different here? Does it actually mean anything tangible for the user?
That's always the right question to ask.
Yeah.
And thankfully, the sources do provide some specifics, cutting through the fluff a bit. This new alloy isn't just standard grade 5. The engineering specs suggest it incorporates specific trace elements tiny amounts of other metals. What these do is subtly change the grain structure of the metal right at the surface. And the practical benefit, improved scratch resistance. We're seeing figures around approximately 15% better resistance to scratches and microabrasions compared to the grade 5 used in the 15 and 16 Pro Max.
Okay, 15% better scratch resistance. That's a solid metric.
It is. And what's really impressive from an engineering standpoint is that they seem to have achieved this extra durability while hitting that same 221-gram weight target. It suggests some very clever alloy design.
And the dimensions. You said the 14, 15, 16 were basically identical. That's quite the feat. But the 17 Pro Max finally tweaks things slightly.
Just marginally, yeah. The specs point to 160.9 by 77.8 millimeters. It's a tiny bit taller and wider.
Yeah.
But interestingly, it's also expected to be slightly thinner, dropping to 7.75 millimeters from 7.85.
Shaving off even a tenth of a millimeter. That must be incredibly difficult when you're also trying to pack in more advanced tech, bigger batteries, new cameras.
It's a huge challenge. That thinness is likely only possible because of advances in other areas, like the display tech and maybe the battery chemistry, which we'll get to. But sticking with design, here's where it gets really interesting, I think. The physical controls, the buttons.
Right. 14 Pro Max had the classic setup.
Yep.
Volume buttons, physical mute switch. Iconic, but mechanical.
Then the 15 Pro Max ditched the mute switch for the action button. That was programmable, had haptic feedback, a step towards something more solid state.
And the 17 Pro Max rumors, they talk about pressure-sensitive zones, getting rid of physical buttons altogether.
Precisely. That seems to be the direction. Instead of moving parts, you'd have these solid-state areas on the frame that detect different levels of pressure. It needs really sensitive sensors, strain gauges, and sophisticated haptic feedback from the Taptic engine to mimic the click.
So why do that? Is it just for looks?
Well, aesthetics might play a part, but the engineering reasons are probably more compelling. Fewer moving parts means fewer points where dust or water can get in. It increases long-term durability and water resistance. Plus, you could potentially assign multiple functions like a light press mutes, a hard press launches the camera, that kind of thing. It's replacing mechanics with software and advanced haptics.
Interesting. We should also quickly touch on the colors because they track the materials, don't they? From deep purple stainless steel on the 14 to the natural titanium, blue, white, black on the 15.
Exactly. Yeah. And the 16 reportedly brought in desert titanium, maybe a lighter, sandier tone. And the 17 is rumored to introduce a crimson titanium. It shows how the finish and the color options are tied directly to the underlying metal they're working with.
Okay, fascinating stuff on the outside. Let's move to what you see constantly. Section 2, display technology. And the big headline seems to be this potential micro-LED leap in the 17 Pro Max.
Right. First, let's set the baseline. The 14, 15, and 16 Pro Max models all used really excellent 6.7-inch Super Retina XDR displays. OLED technology, 460 pixels per inch density, and promotion, allowing that adaptive refresh rate from 1 Hz all the way up to 120 Hz. During those years, the engineering focus was clearly on making OLED more efficient.
And you could actually see that, right? Especially with the always-on display. I remember the 14 Pro Max used maybe 0.8% battery per hour when I was just sitting there showing the time.
Yeah, roughly that. But by the 15 Pro Max, thanks to improvements in the panel itself and probably the A17 Pro chip being more efficient, they got that down to around 0.6% per hour.
That's like a 25% improvement in standby drain just from the display being on. That adds up over a day.
Absolutely. It's a significant efficiency gain for a feature like that. And brightness also steadily increased. The 14 and 15 Pro Max hit a peak of 1,600 nits, which was great, but the 16 Pro Max pushed that further to 2,000 nits peak.
Which really helps outdoors in bright sunlight, I imagine. Makes things much easier to see.
Exactly. That extra brightness combats glare and makes viewing photos or videos outside a much better experience.
Okay, so OLED got progressively better, but the 17 Pro Max, the sources are pointing strongly towards micro-LED. Why is this such a big deal? What's the fundamental difference from OLED?
It's a completely different underlying technology, essentially. OLED stands for Organic Light-Emitting Diode. The organic part is key. It uses carbon-based materials. These materials, unfortunately, degrade over time. It limits their maximum brightness potential and their overall lifespan and can lead to burn-in issues eventually. Micro-LED, on the other hand, uses inorganic materials, typically gallium nitride. These tiny microscopic LEDs are much more stable, they don't degrade like organic compounds, and you can control them with incredible precision.
Okay, inorganic versus organic. So what are the practical benefits for the 17 Pro Max display?
Several huge ones, according to the specs. First, true black levels. Because each pixel is its own light source and can be turned off completely independently, you get perfect blacks with zero light bleed. Contrast ratios become almost infinite. Second, brightness. The stability of inorganic LEDs allows them to be driven harder. The target peak brightness we're seeing for the 17 Pro Max is 2500 nits. That's a substantial jump, pushing HDR content and outdoor visibility even further.
Wow, 2,500 bits. And you mentioned power efficiency earlier. How does micro LED help there?
The granular control and stability are key. It allows for an even wider adaptive refresh rate range. The sources suggest the 17 Pro Max could drop down to as low as zero point 0.1 hertz for static content.
Zero point 0.1 hertz. So the screen only refreshes once every 10 seconds.
Potentially, yeah. If you're just looking at a static page like reading text or an email, it barely needs to update.
Mm.
This incredible efficiency, especially at the low end of the refresh rate, is expected to result in about 15% better overall power efficiency compared to the already efficient OLED panels in the predecessors. That could mean noticeably longer battery life, especially in standby or low activity use.
Incredible brightness, perfect blacks, better efficiency. Sounds like a win all around. But what about color accuracy? For photographers, videographers, that's critical.
Absolutely. And that's another area where micro LED combined with advanced calibration is set to excel. We measure color accuracy using delta E. Lower numbers are better, meaning the color shown is closer to the intended reference color. The 14 Pro Max was already very good, with a delta E around 1.1 for the DCI-P3 color space. Generally, anything under 2 is considered visually indistinguishable for most people. The 15 and 16 Pro Max likely improved on this incrementally. But the target for the 17 Pro Max, according to the technical sources, is a delta E of just 0.5. And that's for both the standard sRGB space and the wider DCI-P3 space used in cinema.
Delta E 0.5. That's basically perfect, isn't it? Like reference monitor territory.
Pretty much. At that level, the color reproduction is virtually indistinguishable from perfect to the human eye. Achieving that requires incredibly sophisticated factory calibration and powerful display controllers managing the micro LED array. For anyone doing color-critical work on their phone, that would be a massive upgrade.
Okay, that covers the look and feel, the materials, the screen. A huge leap coming with micro LED. Let's pause there. We need to move inside the phone now, to the silicon, the brains of the operation, and how it's powered. But first, let's quickly check in again with our sponsor, Face Naturals Organic Skincare.
Yeah, it's interesting. We've just been talking about the intricate engineering needed for peak performance and efficiency in these devices. It's a good reminder to apply that same kind of thinking to, well, ourselves. Our skin, as we said, is fundamental to our health. Knowing it absorbs a significant percentage of what we apply, potentially up to 80%, really highlights why the ingredients in our skincare matter so much. Choosing effective, but also non-toxic ingredients is crucial.
Right. We demand the best materials and tech in our phones. Maybe we should demand the best, safest ingredients for our skin, too. Face Naturals Organic Skincare is built on that principle, providing skincare that's natural, safe, and genuinely effective in supporting your skin's health. You can find out more and explore their products at facenaturals.com. That's FACENATURALS.com. Give your skin the nourishment it deserves and save 10% on your purchase. Healthy skin starts here.
All right, welcome back to our deep dive. We're now heading into section 3, processor and performance. This is the engine room, the source of the speed, and increasingly, the intelligence of these devices. The silicon arms race, as the outline calls it.
And it really is a race. The key driver here is the manufacturing process node, essentially, how small they can make the transistors on the chip. Smaller transistors generally mean more speed, more features, and better power efficiency. So, the iPhone 14 Pro Max launched with the A16 Bionic chip that was built on TSMC's 4-nanometer process, a very capable chip for its time, performance cores running around 3.46 gigahertz. Top of the line back then. Then the 15 Pro Max made the big jump to 3-nanometer with the A17 Pro. That felt like a significant milestone.
It was huge. Moving to 3-nanometer allowed Apple to pack in around 19 billion transistors. For comparison, the A16 had about 16 billion. This density increase enabled higher clock speeds. The performance cores hit 3.78 gigahertz. But crucially, the A17 Pro's redesigned 6-core GPU was the first to bring hardware-accelerated ray tracing to the iPhone. This wasn't just about raw speed, it was about enabling new graphical capabilities, especially for gaming, while also achieving around 20% better performance per watt compared to the A16. Efficiency was a major focus.
So better graphics, more efficient power use. What about the A18 Pro and the 16 Pro Max? Was that another big leap or more refinement?
More like refinement on an enhanced 3-nanometer process node.
Yeah.
Transistor count bumped up slightly to about 20.5 billion. Performance cores nudged up to maybe 3.92 gigahertz. The real story with the 18 Pro, according to the sources, was the neural engine. Its performance reportedly doubled compared to the A17 Pro, reaching 35 trillion operations per second, or TOPS.
Okay, TOPS, trillion operations per second. We need to break that down. What does that actually mean for the person using the phone? What kind of operations are we talking about?
Good question. It's a measure of how fast the dedicated part of the chip designed for AI and machine learning tasks can run. Think about things like recognizing faces in photos, processing your voice for Siri or dictation, enabling features like live text, powering the computational photography. All those smart features rely heavily on the neural engine. So 35 TOPS meant the 16 Pro Max could handle 35 trillion of those kinds of calculations every second. That jump indicated a serious focus on making the phone smarter and faster at AI tasks, processing more complex models right there on the device.
Which leads us to the 17 Pro Max and the A19 Pro. Still 3 nanometer, but an even more advanced version.
That's the expectation, an advanced 3-nanometer process potentially pushing the transistor count to around 23 billion. Performance cores are projected to target speeds of 4.1 gigahertz. That's a solid generational clock speed increase. But again, the headline figure is the neural engine. The target here is a massive jump to 50 TOPS.
50 trillion operations per second. That's nearly triple the neural engine performance of the 14 Pro Max in just 3 years.
Exactly. And what's really fascinating, if the sources are accurate, is how they're achieving this. It's not just about making the existing neural engine cores faster. The A19 Pro is rumored to introduce dedicated AI acceleration cores.
Okay, dedicated cores just for AI. How is that
I
different?
mean specialized hardware blocks designed purely for the types of mathematical operations common in machine learning, things like matrix multiplication. They're incredibly efficient at those specific tasks, much more so than general-purpose CPU or GPU cores. It signals a fundamental architectural shift, prioritizing on-device AI processing. The phone becomes capable of running much larger, more complex AI models instantly without needing to constantly send data back and forth to the cloud. Think faster, more context-aware Siri, more powerful real-time computational photography, maybe even system-wide predictive features.
Right, 50 TOPS sounds impressive, but connecting it to the user experience is key. What could the 17 Pro Max do with that power that the 14 Pro Max or even the 16 Pro Max just couldn't handle?
Well, based on that leap, you could see things like real-time processing of extremely complex video effects. Maybe that ray trace cinematic mode we'll talk about later. More profoundly, it enables much more sophisticated on-device AI. Imagine an assistant that doesn't just react to commands, but truly understands context from multiple apps in real time. Or augmented reality experiences that are far more detailed and responsive because the device can process the environment faster. One source mentioned the potential for the 17 Pro Max to run a large language model with maybe 30 billion parameters entirely locally. That means instant private AI interactions that previously needed a connection to massive data centers. That's the kind of capability unlocked by dedicated AI hardware.
Let's try and ground this in some familiar numbers too. Geekbench scores give a rough idea of CPU performance. The 14 Pro Max was around 1874 single core on Geekbench 5. Where's the 17 Pro Max projected to land?
Projections based on the expected clock speeds and architectural improvements put the A19 Pro's single-core score somewhere around 2290 on Geekbench 5. It's a healthy generational improvement, showing the underlying CPU cores are getting faster too.
But maybe gaming is where you really see the difference.
Often, yes. That's where sustained performance under load matters. The 14 Pro Max could run a demanding game like Genshin Impact at high settings, sustaining maybe 57 frames per second, which was pretty good. The target for the 17 Pro Max, leveraging the A19 Pro and potentially that micro LED display's refresh rate, is consistent 120 FPS gaming, possibly using techniques like adaptive resolution scaling to maintain smoothness, doubling the frame rate while adding complex effects like ray tracing. It's pushing the phone into territory previously occupied by dedicated gaming handhelds. Of course, managing the heat and power draw to sustain that is another engineering feat in itself.
Absolutely. Sustaining that power brings us neatly to Section 4, battery and charging. All this performance needs fuel and efficient management.
Definitely. Let's look at raw capacity first. The Mayon numbers. The 14 Pro Max had a 323 milliamp hour battery. That crept up slightly in the 15 and 16. The estimate for the 17 Pro Max is around 14,891 milliamp.
Okay, so about a 13% increase in physical battery size over 3 generations. That's decent.
It is, but like we discussed with the processors, efficiency gains are arguably just as important, if not more so. Remember those process node shrinks? They directly impact how much power the chip draws. During typical active use browsing, light apps, etc., the 14 Pro Max might have drawn around 3.8 watts. The A17 Pro and the 15 Pro Max brought that down to maybe 3.4 W. The A18 Pro and the 16 likely lowered it further, perhaps to 3.1 W. And the target for the A19 Pro and the 17 Pro Max, thanks to the advanced 3 nanometers process and maybe those AI cores handling tasks efficiently, around 2.7 watts.
Wow, hold on. From 3.8W down to 2.7W average draw. That's nearly a 30% reduction in power consumption for the same kind of tasks.
Exactly, yes. So even if the battery size only increased by 13%, reducing the power draw by almost 30% means the actual endurance, the time you can use the phone, should see a much larger improvement. It's about getting more mileage out of each milliamp hour. That's smart engineering.
And there's more to the battery's story in the 17 Pro Max, right? Something about the chemistry. Silicon nanowire anodes. Sounds very sci-fi.
It's a significant potential breakthrough in battery technology. Most current lithium-ion batteries use graphite for the anode, the part that holds the lithium ions when charged. Graphite works, but it has limits on how much lithium it can store. Silicon, theoretically, can hold about 10 times more lithium ions than graphite by weight. The challenge has always been managing silicon's tendency to swell and crack during charging cycles. Silicon nanowires are one approach to overcome this, providing structure and stability. If Apple implements this in the 17 Pro Max, the sources claim it could improve energy density, the amount of power packed into the same physical space, by as much as 27%.
27% more energy dense. That's huge. That helps explain how they could increase capacity and potentially make the phone slightly thinner.
Precisely. It allows for more MAR in the same volume, or the same AW in a smaller volume. It's a key enabler for improving battery life without making the phone thicker or heavier.
Does this new chemistry affect how long the battery lasts overall? Like the number of charge cycles before it degrades?
That's another potential benefit. The sources suggest that this improved chemistry, combined with better battery management systems, could lead to significantly better long-term health. The target mentioned is maintaining 85% of the original capacity after 1,200 full charge cycles.
1,200 cycles, that's way up from the usual benchmark, isn't it? Usually it's like 80% after 500 cycles.
Exactly, yeah. So achieving 85% after 1,200 cycles would mean the battery degrades much more slowly, extending the useful lifespan of the phone considerably before you notice a significant drop in daily endurance. That's a big deal for longevity and maybe resale value too.
Okay, better capacity, much better efficiency, potentially revolutionary chemistry, and longer lifespan. What about charging speeds? That's been an area where iPhones have sometimes lagged.
It has felt that way. The 14 and 15 Pro Max were capped at around 20W wired charging, which isn't particularly fast compared to some competitors. The 16 Pro Max reportedly made a modest step up to 25W wired and maybe 20W wireless with MagSafe. Still not lightning fast.
So does the 17 Pro Max finally catch up?
It seems like it might make a significant jump. The specifications point towards 35W wired charging and 25W wireless charging support.
35 watts wired, that's a noticeable improvement. How fast would that be in practice?
The claim is that it could achieve a 50% charge from empty in about 22 minutes. That's getting much closer to the speeds offered elsewhere and makes quick top-ups much more practical. Getting half a charge in under 25 minutes really changes how you might manage battery levels throughout the day.
Definitely. Okay, we've covered the engine and the fuel tank. Now for the part that probably drives most upgrades. Section 5, the camera system. This is where hardware, software, silicon speed, and that neural engine all have to come together.
Absolutely. It's arguably the most complex subsystem. Let's start with the main camera sensor, the workhorse. We need to think about light gathering. The 14 and 15 Pro Max shared the same main sensor, 48 megapixels, a sensor size of 11.28 inches, and individual pixel size of 1.22 microns. A very solid sensor for its time. The 16 Pro Max marked the first physical enlargement in this series, moving to a larger 11.14-inch sensor. The pixels also got bigger, at 1.4 microns. That bigger area, sources say, allowed it to gather about 23% more light than the 14-15 sensor.
Right, the bucket analogy. Bigger sensor, bigger pixels, catches more light, especially in dim conditions. So the 17 Pro Max, is it another step up or a bigger leap?
It looks like the big leap for the main sensor. The reports point to a 52-megapixel sensor, a slight bump in resolution, maybe for better cropping or computational stuff. But the physical size increase is dramatic. A 11.03-inch sensor. That's heading towards the 1-inch sensor territory seen in some dedicated cameras. Combine that massive sensor with even larger 1.6 micron pixels and a potentially brighter f1.6 aperture, the physics are clear. The sources calculate this results in a staggering 47% increase in light gathering capability compared to the already improved 16 Pro Max sensor.
47% more light than the 16 Pro Max? That's huge. What does that mean for photos?
Fundamentally better low-light performance. Images should be significantly brighter, cleaner, with less digital noise. It also means that the camera might rely less on extreme computational stacking in some situations, potentially leading to more natural-looking details and textures. Better dynamic range, too, capturing more detail in both shadows and highlights simultaneously.
Okay, a potentially game-changing main sensor. Now what about zoom? The telephoto lens has seen a lot of action recently.
It really has. It's been the most dynamic area. The 14 Pro Max had a traditional 3x optical zoom lens, equivalent to about a 77mm focal length. Standard stuff. The 15 Pro Max introduced the tetraprism designed to achieve 5x optical zoom, 120mm equivalent, without making the phone thicker. That was a clever bit of optical engineering, folding the light path internally using prisms. The 16 Pro Max continued with that 5x tetraprism.
So if the 17 Pro Max is aiming for even more zoom, they must be evolving that folded optics design again.
It seems so. The rumors suggest moving beyond the tetraprism to a more advanced periscope lens design. This would allow them to reach much further, with the target being 7.5x optical zoom.
7.5x optical. That's equivalent to a 150mm lens.
Yeah.
That's serious reach for a phone camera.
It really is. It opens up possibilities for sports, wildlife, or compressing distant landscapes in a way that 3x or even 5x can't quite manage. And crucially, the reports suggest they're pairing this longer reach with a relatively bright aperture for that focal length, maybe around f2.2. That's important for gathering enough light and enabling faster shutter speeds at high zoom levels, reducing blur. Building that entire module reliably in such a small space is a huge engineering task.
Wow. Okay. Massive main sensor upgrade, huge leap in optical zoom. What does all this hardware combined with the A19 Pro's power mean for video? That's increasingly important for professionals.
This is where that 50 TOPS neural engine and the raw horsepower become absolutely essential. The 14 Pro Max topped out at 4K ProRes video at 30 frames per second. Very high quality, but still 4K.
Yeah.
The 17 Pro Max is aiming for 8K ProRes video, also at 30 PSS, potentially with full support for professional color grading workflows baked in.
8K video on a phone. The file sizes must be enormous, and the processing power needed.
Exactly. Recording, processing, encoding, and storing 8K ProRes requires immense sustained performance from the processor, the neural engine, for noise reduction, stabilization, etc., and crucially, the internal storage needs to be fast enough to keep up. It generates 4 times the pixel data of 4K every second. And it's not just resolution. Computational video gets a boost too. Remember cinematic mode. The 17 Pro Max might enable cinematic mode at 4K resolution, but with real-time ray tracing effects applied. Imagine calculating realistic lighting, shadows, and depth of field on the fly for video. That requires the kind of power the A19 Pro promises. It's moving from simple capture towards real-time computational filmmaking.
Mind-boggling stuff. Okay, let's round things out with Section 6. Connectivity, storage, and the sort of underlying infrastructure bits, keeping everything connected and flowing.
All right, got to keep up with the wireless standards. The 14 Pro Max had Wi-Fi 6 and Bluetooth 5.3, pretty standard for the time. The 15 Pro Max added Wi-Fi 6E. That was important because it opened up access to the newer, less crowded 6 GHz frequency band. Good for faster speeds and less congested areas, though range is shorter. The 16 Pro Max is expected to make the jump to Wi-Fi 7, also known as 802.1 WB. This is a bigger deal. It offers wider channel bandwidth, up to 320 BHz, and more sophisticated ways to combine frequencies. Theoretical speeds jump way up, potentially towards 5.8 gigabits per second.
Wi-Fi 7, is that necessary just for browsing?
Maybe not for casual browsing, but think about downloading or uploading those massive 8K video files we just talked about, or streaming ultra-high-res content or low-latency cloud gaming. That's where Wi-Fi 7's speed and capacity start to make a real difference.
Yeah.
And the 17 Pro Max looks set to enhance Wi-Fi 7 further by implementing 4x4 MIMO.
Okay, MIMO, multiple input, multiple output. What does 4x4 mean in plain English?
It means the phone uses 4 antennas simultaneously for both sending and receiving data over Wi-Fi. Most phones might use 2x2. Using 4 antennas drastically increases the robustness and efficiency of the connection, especially in crowded Wi-Fi environments. It helps maintain higher speeds more consistently and improves overall throughput. It's about making the most of that potential 5.8 Gbp speed promised by Wi-Fi 7.
Got it. Better, faster, more reliable Wi-Fi. What about cellular and satellite?
Cellular will obviously see continued 5G enhancements, likely supporting newer bands and aggregation techniques for faster speeds where available. The interesting bit is the satellite connectivity. It started with emergency SOS on the 14 series. The 17 Pro Max is rumored to upgrade this to emergency SOS Plus, enabling two-way satellite messaging.
Two-way, so you could actually have a limited conversation via satellite.
Potentially, yes. Not like a normal text chat. But enough for confirming help is on the way, providing updates or receiving simple instructions in emergency situations far outside cellular range. It makes the feature significantly more robust and useful as a safety tool.
That makes sense. Now, storage. With 8K video becoming a thing, storage needs must be exploding.
Absolutely, the base storage has been creeping up. The 14 Pro Max still started at 128 GB. The 15 Pro Max dropped that, starting at 256 GB. The 17 Pro Max is anticipated to possibly drop the 256 GB option, starting at 512 GB, and crucially adding a new top tier, 4 terabytes.
4 terabytes in a phone.
It sounds insane, but if you're shooting hours of 8K ProRes video, you'll fill up 1 TB surprisingly quickly. That 4 TB option is clearly aimed at the highest-end professional users who are pushing the device to its absolute limits for content creation.
And that storage needs to be fast, right? Not just big.
Essential. If the storage can't write data quickly enough, you can't sustain 8K recording. If it can't read quickly enough, editing or running large AI models becomes sluggish. We measured this with sequential read-write speeds. The 14 Pro Max had fast storage for its time, maybe around 1850 megabytes per second read speed. The target for the 17 Pro Max, to support all these demanding features, is likely closer to totaling 850 megabytes read speed. That's over a 50% increase in raw data transfer speed internally. It ensures the whole system processor, RAM, storage works together without bottlenecks.
Makes sense. Any quick notes on other bits like audio or software?
Yeah, the 17 Pro Max is rumored to feature some kind of adaptive frequency response audio technology, possibly using the microphones to analyze the room acoustics or the content type and adjusting the speaker output for better clarity or bass. Minor compared to the camera or chip, but still an evolution. And underpinning everything, of course, will be the next version of the operating system, presumably iOS 19. That's where we'll likely see the software features designed to truly leverage that 50 TOPS neural engine, bringing more AI capabilities system-wide.
Okay, an incredible amount of technical evolution packed into 3 years. Before we try and tie this all together for an upgrade decision, let's take one final pause to think about conscious choices, starting with our sponsor. We've just detailed some amazing engineering designed for peak performance. It's worth asking if we apply the same care to the choices we make for our own body's performance and protection.
Exactly. Your skin is working 24/7 to protect you. Knowing how readily it absorbs what you apply really emphasizes the importance of choosing ingredients wisely. Why settle for potentially harmful chemicals when natural supportive options exist?
Face Naturals Organic Skincare champions that philosophy, nurturing your skin with ingredients that are safe, effective, and work in harmony with your body's health. Visit facenaturals.com one last time. Check out their natural skincare range and get 10% off your next purchase. Support your skin's health naturally. Healthy skin starts here.
All right, we've reached the finish line, the conclusion and upgrade analysis. We've laid out the engineering differences, the quantifiable leaps from the 14 Pro Max through to the anticipated 17 Pro Max. Now the big question, who should upgrade and when? Let's apply this data to you, the listener.
Okay, let's break it down by starting point. If you're currently using an iPhone 14 Pro Max, upgrading to the 17 Pro Max represents, frankly, a massive leap. You're getting a whole different device in many ways. You go from heavy stainless steel to lighter, tougher titanium. You jump from 4mm silicon to advanced 3nm with a vastly more powerful neural engine. You get the micro LED display revolution instead of OLED. The main camera sensor is hugely upgraded, and you go from 3x optical zoom all the way to 7.5x. Plus, much faster charging and potentially that silicon nanowire battery tech for better longevity. For 14 Pro Max owners, the improvements are across the board and undeniably substantial. It's a very compelling upgrade.
Okay, clear benefits for 14 Pro Max users. What about someone with a 15 Pro Max? They already have titanium, the action button, 5x zoom.
Right, for 15 Pro Max owners, the jump is more moderate, but still significant in key areas. The performance boost from A17 Pro to A19 Pro will be noticeable, especially for demanding tasks or future AI features. But the biggest differentiators are likely the display and the camera system. You gain that micro LED screen with its higher brightness and efficiency. You get the much larger main camera sensor for better low light, and the jump from 5x to 7.5x telephoto is a significant increase in reach. Add in the potential battery density longevity improvements and the faster 35W charging. If you're a heavy camera user, value display quality, or push battery life to its limits, the 17 Pro Max still offers a very meaningful upgrade over the 15 Pro Max.
So, still compelling, especially for creators or power users.
Right.
Now, the toughest one. What if you had the 16 Pro Max, the immediate predecessor?
Yeah, this is where the upgrade becomes much more marginal and specific. The 16 Pro Max already has a refined 3nm chip, A18 Pro. The larger main sensor, though not as large as the 17's, 5x zoom, and likely Wi-Fi 7. The key advantages of the 17 Pro Max over the 16 Pro Max really boil down to a few high-end features. That final jump from 5x to 7.5x optical zoom. The capability to shoot and handle native 8K ProRes video. The absolute peak power efficiency potentially offered by the A19 Pro and Micro LED combo, that 2.7W draw. And maybe the bleeding-edge Wi-Fi 7 with 4x4 MIMO if your network supports it fully. If you are a professional whose workflow demands 8K video, or if that extra telephoto reach is critical for your photography, then yes, the upgrade could be justified. But for the average user coming from a 16 Pro Max, the real-world difference might feel smaller, perhaps centered mostly on potential battery endurance gains and maybe that brighter screen. It's a much tougher sell based purely on specs.
That makes sense. It really depends on your starting point and what specific features you value most. We've tried to lay out the hard data, the engineering reality, so you can make that call for yourself, separating the genuine advancements from the marketing gloss. But let's end with a final provocative thought for you to chew on. We've talked a lot about the camera hardware, the 52MP sensor, the 7.5x lens, 8K video. These are often the headline reasons people upgrade. But maybe the real revolution isn't just the hardware capturing the image, but what happens next. With that massive leap in the neural engine to 50 TOPS in the A19 Pro, how will that fundamentally change what's possible after you press the shutter button? Think about computational photography, real-time analysis, maybe even predictive AI shaping your experience based on that immense on-device processing power. Are we ready for phones that don't just capture moments, but actively interpret and potentially alter our reality through sophisticated, instantaneous AI? That's the frontier where this raw power meets our digital lives. Something to consider. Thank you so much for listening to Life Redacted. We truly appreciate having you join us each week to explore the life, insights, and conversations that matter. Your support means the world to us, and honestly, it's what keeps us going. If you enjoy what you hear, please consider subscribing to stay updated on our latest episodes, and give us a like to let us know you're enjoying the show. It really helps us reach more listeners just like you.